Good morning, aspirant. Hope you all are doing well. Your days are going productive and you are doing excellent in your studies. So, till now, what we have seen, first, we have seen the basic of quantum mechanics, then mathematics, then we have seen the function and operators, and we were studying the properties of operator. 1, 2, 3, 4. In fourth property, we have seen observable and their different quantum mechanical operators. Here we have seen the position, momentum, linear momentum, angular momentum, total kinetic energy, potential energy, total energy. Okay. In fifth property, we have seen operator, and in operator nahi, commutator. In fifth property, we have seen commutator. And in the last class, we have understood what commutator is, and we will be understanding its property. Okay. Now, let's understand commutator. Properties of commutator. First, commutator is antisymmetric in nature. It is antisymmetric in nature. What does that mean? It is antisymmetric in nature. That means you have to have a better look on functions. If f of x equal to f of minus x, we called it is a symmetrical function. If f of x not equal to f of minus x, we call it asymmetric function. It is not asymmetric, but in asymmetric there is a special case. If f of x equal to minus f of minus x, then it will be called anti-symmetric. For example, graphically, if it is a symmetric function plus its corresponding graphical function will show like this. This is plus, this is minus. So it was symmetric, it is anti-symmetric. Okay. Now how will we prove the anti-symmetric nature of a commutator? Let's prove. AB means AB minus BA equal to minus of BA minus AB. The way in which we have concluded this, the same way we can write this as BA minus AB means commutator of B comma A, right? And minus is there. Okay. So commutator AB is equal to minus of commutator BA. Clear? So why I am teaching you this? Why I am teaching you this? Because in the quantum mechanical calculation, there will be so many involvement of different operators, and you have to know where you can reverse it, where you cannot, where you can reverse it or put a minus before that, where you cannot. Okay. For example, if A and B commutes, then this will be 0, this will be minus 0. If they do not commute, still this relation is true. So that means the antisymmetric property, it doesn't matter two operator commutes or not. Okay. Now this is the first property. Second property is, it is called property of linearity. Is called property of linearity. What does that mean? Linearity means, for example, if in any mathematical calculation in quantum mechanics you get like this, there is an operator and it is commutator of B plus C, three operators like this. How will you solve it? How you will solve a complex relation in operators? So commutator of this, we know commutator of A comma B means AB minus BA, right? But if there is just two things, here I have, what I have done, I have changed the B like something x plus y. Now how will you approach? First you will take A with B. First you will write A comma, first you will A with B, then you will use this sign, then you will use A with C. A B, there is a plus sign, then A comma C. Okay. Now you write this AB minus BA plus AC minus CA, right? AC minus CA. Thus you will solve it. Okay. Similarly, you can practice like this: A plus B comma C. What will be its value? Now C is in right hand side, so you will make two box obviously. You will make two box obviously. You will put plus sign between it. Okay. Now first C will be with A, next C will be with B. The sequence must not break. So A C B C. Got it? So AC minus CA plus BC minus CB. This is how you are going to write this. Okay, got it? Now try by yourself how you will solve if something is given A plus B comma C plus D. How will you solve? In this way, how will you reach simplify it? Try this. So first you use A with C plus D, A comma C plus D plus B comma C plus D, right? Now this you will further solve is like A C, A comma C plus A comma D plus B comma C plus B comma D, right? So you will write AC minus CA plus AD minus DA plus BC minus CB plus BD minus DB, right? Thus we will solve. Clear? Why we are just doing this nonsense? Say in a practical implication, suppose Hamiltonian operator is operating on position. How will you solve this? We will be going to solve this and we'll be understanding why we are going to solve this. Suppose in practical essence, Hamiltonian is an operating on position operator. Then how you will write? We know Hamiltonian means basically kinetic energy operator plus potential energy operator, right? And so individually these will operate on position. So how will you write this? Tx plus Vx, right? So Tx means xtx minus xt plus Vx minus xv, right? So this mathematical approach is quite different from the conventional mathematics we do. Okay. So we have understood two properties of commutator, right? So one is asymmetric nature, second is linearity. Third property, it is called distributivity. Distributivity. What does this property mean? Suppose there is something A comma BC. So initially what we were doing, we were saying that AB means AB minus BA. First we have done A, we were splitting like something plus something, or we were splitting B like something plus something. Then we were saying this was the property of linearity. What if B is combination of another two operator which is in multiplication relation? Then how we are going to approach it? Now this is a bit difficult. Follow me very, very carefully. BC, you will write B here and you will write C here. We will put bracket here. Okay. First, B is already there, so A and C are left. So we will write A, C. And here C is already there. You will write A and B. So first, those two who are in multiplicative relation, left one, write it an extreme left, right one, write it like an extreme right. Then see which one is missing. Then obviously after third bracket, see which one is missing. If you put B, then A and C are missing. First A, then C. First A, then C. And here C is already present, so first A and then B. Okay, clear? Then tell me how you will write AB comma C. How you will write this? Tell me. So obviously these two are in multiplicative relation. So extreme left you will be write A as A is in left. Here you will write B. No issues. Obviously there will be positive sign. Okay. Now here A is present. In first this zone A is present, so B or C left. So B comma C. Second zone B is already there, so A, C left. A comma C. Okay. So this will be basically A. B or C operator means BC minus CA, isn't it? Plus AC minus CA, then B. Okay. Got it? No problem. Now A difficult one? Try this. A comma B, sorry, A operator comma B C D operator. What you will write? First you will take AB as an operator, C comma D left, right, plus then you will take A and C, you will take A and C, you will take A and C, but B and D are in two opposite direction of C, so we will write B here, D here, plus now AD will be there, AD will be there, but B and C are at left, B and C are at left. Okay, you can write this way also, you can think in this way also. A comma BC, suppose for example there is A comma BC, then first you are taking A with B, then A you are writing AB commutator, then C is at the right, so write C, plus then take A comma C, take A comma C. When you are taking A comma C, B is at the left or right, you are taking A and C, you are taking A and C, so B is at the left side of this conjugate, so this will be B. Okay, so ABC plus BAC, ABC plus BAC, same thing. Okay, so this way you can write it also. Okay, now we have to solve some questions. Okay, I will give you total 6-7 questions. In this lecture, just learn this up to this point. In the next session, we will be solving questions on this.